So I wanted to take a look at some what I call useful relationships. Just quick things that you can look at and kind of come up with some answers depending on how things are configured. In this case, we're talking about a series connection, and we know that there's a current that flows I sub t, excuse me, and so we can come up with the uh, relationship of the voltage across resistor N is equal to the current times resistor N. And now I can substitute for the current, and the current is just the total voltage divided by the total resistance, because the current has to be the same through all of them, times Rn. Now this is an interesting relationship because it basically just says that the voltage potential across each resistor is just a weighted average across each one. So it's like taking the pie and cutting it into pieces. So if I have my whole pie, which is V sub t, then I can look at one part of that being V1, one part of that being V2, one part of that being V3. It's just giving you percentages of the total, and those percentages are based off of Rn over Rt. This would be R3, I'm sorry, R3. This would be R2 over RT, and R1 over RT. So it's just percentages of that pie. For our next relationship, we have two resistors that are in parallel. So we can take 1 over RT equals 1 over R1 plus 1 over R2. We need to get common denominators, so I'm going to take and multiply this fraction, R2 over R1, R2, plus, and I'm going to take this fraction and multiply by R1 over R1. Now I can combine them. And if I take the reciprocal, then I get R1 times R2 over R1 plus R2. This only works for 2. Works for 2 resistors in parallel. Many students think that if it's 3 resistors, it would look something like this. That it would be R1, R2, R3, over R1 plus R2 plus R3. And that is not correct. That is not what it is. For 3 resistors, it actually turns out to be RT is equal to R1, R2, R3 over R1, R2 plus R1, R3 plus R2, R3. Now, there have been a lot of mathematicians and computer scientists who have looked at these formulas. For 2 resistors, this takes less calculations than using the reciprocal formula. This is more calculations. But if I were to do for 3 resistors, 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, well, it turns out that this has the less calculations. This has more. So this relationship really only works well with 2 resistors. Once you get into 3, then you're actually doing more work than you would do otherwise. So that's why I highlight the 2 resistor combination. And for our last relationship, we have a parallel circuit, and I know that this actually I wanted to be T, forgot to change that. I know that my voltage across I know that the current, I wanted to go for current here. The current through Rn, whichever resistor I want, is equal to Vt over Rn. But Vt is just equal to I times RT, and I'll divide that by Rn, and now I get the current through the specific resistor that I want based on its configuration. Now, this is rarely used, but sometimes you'll see people use it, but it's rarely used. And the reason is that I'd have to go through and calculate my total resistance. It's not as easy as a series circuit, and if I knew this, then I could use it for calculating all the currents if I needed. But typically it's not rarely used. There are other methods that you can use to actually solve this.